In this video, we're going to look at the most challenging linear systems. Those linear systems that will require the most work in order for you to find the common solution. Here, we've shown the same linear system twice, once in blue and then again here in red. I want you to take a look at this linear system and think to yourself which method would be most efficient for me to use in solving this linear system. Pause the video, figure out which method you would want to use. Welcome back. Many of you are probably thinking, I don't know which method I want to use for this. Neither method looks particularly appealing. If I wanted to pursue substitution, I look at the first equation, negative 6x plus 2y equals negative 10, and I say nothing there is ready for substitution. It doesn't say x equals a bunch of stuff. It doesn't say y equals stuff. How am I going to substitute using the first equation? Or how could I substitute using the second equation? So you then might think, well, let's use elimination here. But again, we run into a problem. If I were to combine these two equations, the negative 6x is not going to eliminate the 8x, and the positive 2y is not going to eliminate the negative 6y. So if I combine these two equations, neither variable will disappear or eliminate, and I'll be stuck with the same problem. An equation with an x and a y. How do I figure out what just one of the x or the y's might be? When I run into this linear system, first off, I can recognize this is a challenging linear system. It's going to take some extra work. The extra work is going to come in the form of transforming or changing one of the equations in the beginning so that it is the type of linear system that can be solved by either substitution or elimination. First, we're going to show you how to take this blue equation and solve it by using elimination. I recognize that negative 6y and positive 2y won't eliminate, but if I could somehow change that first equation to have a positive 6y, it would eliminate with the negative 6y. What number do I need to multiply positive 2y by to get it to be positive 6y? I need to multiply it by 3, or positive 3. Now in doing so, the only reason I'm allowed to multiply this equation or this term by positive 3 is if I multiply every single term in the equation by positive 3 so that the equation remains true. When I do that, negative 6x times positive 3 becomes negative 18x. Positive 2y times 3 becomes positive 6y, which is what we wanted to eliminate the negative 6y. And negative 10 times positive 3 becomes negative 30. Now we have two linear equations in our system that would result in elimination, where if we combine these two equations, the y's would both eliminate with each other, the positive 6y and negative 6y being inverses, and the only thing on the left side of our equation would be negative 18x plus 8x, or negative 10x when we combine those like terms. The right side would combine our negative 30 with positive 10, leaving us with negative 20. And now this linear system is starting to look like something we can solve for x, and again would use that x to then figure out what y is eventually. I also could have pursued this linear system through substitution. Again, I was going to need to transform or change one equation to get it ready for substitution. We're going to work with the first equation. I see the positive 2y, and I recognize if I could get this positive 2y alone, I could just divide by 2 and get the y alone. If it said what y equals, I could use it for substitution. So we're going to take this red equation, and we're going to go ahead and transform it, or change it by solving for y. We want to get the y all alone on the left side of this equation, so we know what y is equal to and can substitute with that. I need to remove the negative 6x from the left side first, or peel the onion, as Mr. Neville would say last year. So I'm going to add 6x. I'm going to do an inverse operation to get rid of that negative 6x over there on the left side. In doing so, I need to remember to add 6x to the right side as well. And that's going to give us a new equation that shows 2y all by itself on the left side now. And the right expression, I can't combine negative 10 with positive 6x. They have different last names. So they're just going to separately stay there as negative 10 plus 6x. We're now close to getting this equation to say what y equals. We would need to divide by 2 to remove the times by 2. Each term gets divided by 2. That leaves us with y equals negative 5 plus 3x after everything's divided by 2. And now this equation could be used to substitute into the second equation that we originally had in our linear system, 8x minus 6y equals 10. Now I could replace the y with negative 5 plus 3x, which still needs to get distributed with that negative 6. And at this point, we now have a linear system that has all x's for one of the linear equations, and then we could solve to find x and ultimately get y. As you can see here, in many of these cases when it is not built for either situation, substitution does take a few extra steps. But you should go with whichever method makes sense and whichever method can help you reach the right answer on one of these very challenging linear systems.